Good day, all. Welcome to this month's PNW Drought and Climate Outlook webinar. My name is Holly Prendeville, and I'm with the USDA Northwest Climate Hub. This bi-monthly webinar series is hosted by NIDIS, the National Integrated Drought Information System, the USDA Northwest Climate Hub, and OCRI, the Oregon Climate Change Research Institute. This webinar is designed to provide partners and other interested parties in the Pacific Northwest with its timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and other climatic events. Each webinar will discuss observed impacts and other relevant updates from across the region. Webinars, recordings, and other supporting materials will be posted on drought.gov later this week. If you've signed up for the newsletters, you'll receive notifications when those are available. At the end of today's webinar, you'll be able to provide us feedback that will help us improve the webinar series. Please take a moment and let us know what you think. Today's speakers include Larry O'Neill from Oregon State University, who will provide the climate recap and current conditions presentation, followed by Henry Pye with the Pacific Northwest River Forecast Center, who will provide the seasonal conditions and climate outlook webinar. And then Alexis Mills with the U.S. Army Corps of Engineers will discuss the Columbia Basin water management overview and current conditions. And then we will hear from Urban Eberhardt from the Kittitas Reclamation District, who will discuss their water supply impacts and drought resiliency strategies. There's a question and answer box up at the top. It's a little square with a question mark in it, the top on the right, and that is where you can post your questions. We will take questions and address them at the end of all 4 presentations. Before we begin our presentations, we'd like to highlight our partners that help us make this webinar series possible. The Northwest Climate Hub develops science-based, region-specific information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Oregon, Washington, and Alaska. Links for each of these web pages and items we'll be sharing will be posted in the chat box. OCRI, the Oregon Climate Change Research Institute, is a network of researchers at Oregon's public universities who work with public and private entities to advance understanding of regional climate and climate adaptation. OCRI is administered by Oregon State University and hosts the Oregon Climate Service and the Office of the State Climatologist of Oregon. Apologies. NIDIS was established in 2006 by public law, with the mission of improving the nation's capacity to proactively manage drought-related risks. NIDIS provides the best information and resources available to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS maintains the foundation of a national drought early warning system through the development of regional dues, as shown in this map, where networks of partners and interested and affected parties share information and actions that can help communities cope with drought. Although the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ among regions. The regional dues have many of the same basic features, but each has a distinct aspect and reflects the needs of the region. The Pacific Northwest Drought Early Warning System was launched in February 2016, and the strategic plan and current activities are available on drought.gov. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join COCORAS, the Community Collaborative Rain, Hail, and Snow Network. This unique, nonprofit, community-based network of volunteers of all ages and backgrounds who work together to measure, map, rain, hail, and snow, and report these conditions. Observers record precipitation events, as well as the lack of precipitation, as we're experiencing at the moment, and share important ways for helping us understand the weather. To become a volunteer and learn more about COCORAS, you can contact your local state coordinator. The names and their emails will be available in the chat. Understanding how drought impacts you is important for drought assessment at the state, regional, and national levels. The National Drought Mitigation Center has a Condition Monitoring Observer Reporting System, or CMOR. It's a great way to submit impacts you're experiencing from either too much or too little precipitation. Becoming a regular observer makes this information more accessible to those who have access to drought in your state, to assess drought in your state, and we'll pull this information for the annual Pacific Northwest Water Year Impacts Assessment to see what was recorded. In the Seymour website, there are how-to videos, best practices, and ways to access their information. You can find that in the chat. There are new ways to stay in touch with NIDIS. In the past, if you've registered for a webinar, we were able to get you on the PNW email news list so that you would receive the recording. This is no longer the case. So if you've come across this webinar in another way, other than a direct email to you, and you would like to receive future information and recordings pertinent to this webinar, please click on the link in the chat. You might also be interested in the bi-weekly Dry Times newsletter or the Tribal Engagement newsletter. Now we'll begin with our first speaker, Larry.
Hi, good morning, everyone. I can't seem to share.
How about now?
Yeah, wonderful, thanks. So good morning, everyone. My name is Larry O'Neill, and I'm the state climatologist of Oregon, and I'm from Oregon State and the Oregon Climate Service. And I'll be giving this month's condition summary for the Pacific Northwest. And basically, this summer has been really dry, and we've seen a lot of increases in drought severity and extent. And a good way to look at that is the U.S. Drought Monitor change over since mid-June when we had the last DEWS webinar. And this is conditions at that time, on June 24th. At that time, about 48% of the Pacific Northwest was in some form of drought, and the most severe form was D2 or severe drought, which covered about 12% of the Pacific Northwest, and then a little bit of D3 that was creeping up into western Montana. Fast forward 2 months, and this is the latest U.S. Drought Monitor right now, and currently 81% of the Pacific Northwest is in some form of drought, and this includes the most severe places. We have extreme drought in the North Washington Cascades, and then in the northern Idaho Panhandle and into western Montana. And then we have actually a spot of D4 or exceptional drought also in northwestern or in northern Idaho. Good news is that the southern part of Oregon is currently free from any abnormally dry conditions, which is a welcome change from the last several years. We've also had a lot of drought declarations, state-level drought declarations, and this just shows a map for current drought declarations that have been made by each state and county within Oregon, Washington, and Idaho. Right now, 7 counties in Oregon and 2 in Idaho have approved drought declarations, and then the large swath of Washington, including the Cascades and into eastern Washington and parts of the Olympic Peninsula, have a drought emergency declaration, and then a large swath of areas around the Puget Sound, including Seattle, Tacoma, and Olympia, have a drought advisory currently. So right now, conditions, we've gone into these drought conditions, and it's been very, we're starting to see some really adverse impacts from that across the Pacific Northwest, unfortunately. So how did we find ourselves into this situation? Essentially, it's a lack of precipitation since early April that has driven a lot of the drought severity, a lot of the increases in drought severity throughout the Pacific Northwest. And over the last 90 days, this just shows a map of the percent normal of precipitation. And the warm colors are drier than normal or less precipitation normal, and then the green colors are more or wetter conditions than normal. And most of the Pacific Northwest, we've had less than 30 to 50% of normal precipitation for that time. So conditions have been really dry throughout here. Once we get west of the Rocky Mountains and into western or eastern Montana and Wyoming, they're having wetter than normal conditions. and that is their wet season, so it's a really good sign there. But for us, for the most part, it's been very dry here. And when you look at the state precipitation rankings for the period between April and July, when the latest statistics were available, Oregon has received its fourth driest period in that time, Washington its third driest, and Idaho its seventh driest. Montana is about in the middle. They're about average for this time of year for the whole state, and that kind of balances the really dry west with the really wet east. So overall, it's been a very dry end of the spring and start to the summer. Once we start to look at the calendar year for 2025, things don't look so bad. We're kind of in the middle. We're still accruing precipitation deficits in Idaho, Montana, and Washington, but it's about normal for this year, and that kind of shows that the relatively wet winter that we had was a good sign. And yeah, so we also had this atmospheric river event in mid-August, about a week or two ago. And this is just kind of a nice picture of it. So an atmospheric river is nothing more than a cold front with a lot of moisture transport into it. And we did get some really beneficial rain from that throughout Western Oregon and Washington, especially Washington. We had some localized amounts of 6 to 10 inches in the Olympic Peninsula and in the North Oregon or North Washington Cascade Range. But values quickly reduced as you move south. So the core of the atmospheric river kind of hits Washington and Vancouver. So in Oregon, we didn't get much more than an inch in the coastal mountains and the Cascade Mountains here. So this was really beneficial, but it was not quite enough to end the really severe drought conditions in a lot of the Pacific Northwest, unfortunately. So with the really dry conditions, it was also quite warm. And this just shows a map of the temperature anomalies for the last 90 days. And across most of the Pacific Northwest, we had a much warmer than normal start to the summer with average temperature anomalies between about 2 and 4 degrees Fahrenheit and kind of widespread everywhere. And when you look at the state temperature rankings, surprisingly, Oregon and Washington experienced one of the warmest June through Julys on record. So fourth warmest in Washington and sixth warmest in Oregon and 13th warmest in Idaho here. And so this has pushed our calendar year temperature rankings to much warmer than normal. And this is kind of offsetting the really cool start to the year that the Pacific Northwest experienced here. So these warmer temperatures did drive, one of the things we worry about with excessive temperatures in drought, in the formation of drought conditions is how it contributes to evaporative demand, especially during the spring and summer. And to measure that, we use what's called an evaporative drought demand index, or the EDDI, and this just measures how much above or below normal evaporation was from the landscape. And so how much is the atmosphere sucking out of the soil and fuels across the state. And the warm colors here indicate that we had more evaporation than normal, so we had more water being kind of sucked out of the landscape. So this was a really contributing factor to the drought formation across much of the state, especially in Western Oregon, and then also in Eastern Washington, Northeast Oregon, and the Idaho Peninsula here. And the numbers here just kind of correspond to about what an equivalent drought severity would be on the U.S. drought monitor here. So excessive evaporation has definitely contributed to our drought, in addition to the precipitation deficits that we had throughout the state. And one of the most consequential impacts from these precipitation deficits and the excessive evaporation is the effect it's had on our stream flows. And this just shows the stream flow classification over the last 45 days from the USGS Stream Flow Monitoring Network. And these are just by state. So we've got Washington, Oregon, and Idaho. And what is depicted here are the percentage of stream gauges that are within a certain flow category. So all the dry colors, the orange colors, are below normal stream flows. And then the cooler colors, the greens and the blues, are either average or above average stream flows. And in all three states, we've had majority of the streamflow gauges have been below normal throughout the last 45 days. The worst state is in Washington, where going into that atmospheric river event in the middle of August, about 75% of the streamflow gauges were below normal, and about 10% of the streamflow gauges were at record lows for those days. The same situation also held in Oregon, although not quite as severe as Washington, and the same thing for Idaho here. What was nice about that atmospheric river event in Washington is that we actually got some good recovery on a lot of the streams, and we actually had a few record high stream flow, flow events that occurred in association with all that rain too. So that we've been monitoring the impacts of drought, the adverse impacts of drought, and one of the tools that we use is the the Seymour reports that Holly mentioned earlier. And this is a map of all the Seymour reports that we've seen submitted since April 1st of this year. And so we've seen that, and then under that is the current U.S. drought monitor depiction. And we've seen a lot of, actually all these dots here, the red colors indicate impacts that are associated with dry conditions, and then the blue or green colors are impacts associated with wet conditions. And overwhelmingly, there's a lot of dry impacts that we're observing throughout the region, especially in kind of Northeast Oregon and in Montana as well here. So if you or anyone else that you know have impacts to report, please consider using this, because it's a great tool for us to understand how these dry conditions are affecting basically the people, livestock, agricultural production, etc. from there. So just to summarize, we've experienced a really dry spring and summer, and mainly in response to large precipitation deficits and some excessive evaporation. And what we're really experiencing is a lot of low summer stream flows throughout the Northwest. And we have several state-level drought declarations that are in effect. And while that mid-August atmospheric river precipitation event was beneficial, it did not end the drought or the wildfire season. So thank you.
Thank you very much, Larry, for that recap. Next, we'll go over to Henry to get the seasonal conditions and climate outlook.
Okay, hopefully y'all could hear me.
Yes.
Okay, and I'm hopefully starting to share my screen. And
That's
I
good.
will jump. Okay, thanks. Yeah, I will jump right in. Again, thanks for the introduction. I work at the Northwest River Forecast Center in Portland, Oregon. Yeah, I'm Henry Pye. I'm filling in for Amy Burke, who gave maybe the last talk from the River Forecast Center back in late April. And just here is our contact information if you ever have a water supply related question. Now, just jumping right in, key takeaways up front. It's been drier and warmer than normal, as Larry has noted, since April, essentially, and that's driven observed stream flow with many gauges below normal that, again, Larry helped point out. Our water supply forecast continue to be well below normal across the Pacific Northwest with some degradations, which we'll look at later, but we do have a pretty clear drier signal persisting in much of the northern portion of the basin. And then finally, forecast for the remainder of the season, which isn't very much since we're at summer base flows, but La Nina is predicted for next fall or the October, November, December timeframe. Now, here's a pretty busy slide here. So the top row is a snapshot of maps taken from Amy's talk on April 27th. And on the bottom row is a snapshot pretty recently, August 23rd. I do want to highlight that all water supply product flows are naturalized flows with reservoir impacts removed. So starting on the left-hand side, or the left plots here, we've got the October through April 27th runoff on the top left. And then we have October through essentially a few days ago observed runoff in the bottom left. And just these points on the map are individual river gauges or reservoir projects, kind of big ones that we forecast in our basin. The color scale here is similar to what we've been looking at. Green is near normal or 90 to 110 percentile range. Cooler colors indicate wetter than normal, and then the warmer colors indicate drier than normal. And then really what I wanted to highlight, since since we have the prior talks slide up in the top left, is just looking for the color changes. And so again, we see since last April, a lot of yellows in that Washington, Idaho panhandle. Western Montana has some oranges, but they have largely been crowded out by mostly oranges here. And I also wanted to highlight another big area that has changed, and that was in the upper Snake here, kind of in the southeast Idaho, kind of western Wyoming area. And that area has also seen quite a bit of decline in observed runoff. And now the center panel here is our April to September forecast. Just keep in mind that we're already well into that April to September timeframe. So it's almost mostly observed with maybe a little bit over a month of forecast left. And so essentially this is kind of gives you a different way of looking at the observed kind of the volume runoff. So this is kind of geared more towards irrigation season for that April through September timeframe. And again, kind of highlighting the change since last month. But I also wanted to highlight, this forecast, the April to September looks very similar to our October through current runoff, with exception here for the Willamette and some of the basins that flow off to the west side of the Cascades. So a lot of the precipitation tends to happen earlier in the year. These aren't very as big of a snowpack accumulation or snowpack runoff as much impact as, say, places east of the Cascades. And then finally, the right-hand plot is April through September forecasts presented as percentiles. And so the prior two plots, the left and center, were percents of normal. These is just looking at the distribution of it. And so as an example here, we have Revelstoke in kind of the British Columbia area here, some of the snowpack flowing off the Canadian Rockies. Even though that's riding at 90% of normal in the April to September forecast, it is denoted as kind of the drier signal, which is kind of in the 20 to 10 to 20 percentile driest time or observed or forecasted April to September forecast there. So taking a different look at it, just in case whatever kind of helps makes the decision makers make a better decision there. So we might say, what happened? Larry went over a lot of this, but this is, again, a busy slide of precipitation, snow, and river time series. The left-hand panel is observed precipitation generated from our office. The map here is kind of each polygon here is of individual watersheds that we forecast. Did want to highlight this graphic looks a lot different than some of our forecasted runoff. So there are some near normals, say in some of the lower valley areas, but we do see some persistent low biases denoted by the warmer colors, particularly along the Rocky Mountain Range, so extending here from southern Canada, the Montana, and then that Wyoming, southeast Idaho area. And that kind of stretches into this interior that we also saw some very dry signals that Larry was pointing at before. And then also wanted to highlight the Washington Cascades, which has also seen a lot of deficits in seasonal precipitation, and that is accumulated through the water year. And now looking at a time series plot on the bottom, this is a accumulation of Columbia Basin above the Dalles River. The x-axis starts at the beginning of the water year. The y-axis is accumulated precipitation. The dotted line is the 30-year average based on 1991 to 2020. The dark blue, the bold blue line is our current water year. And then the two other thinner lines in orange is last water year, and the green-blue line or teal line in the back there is water year 2023. And then just wanted to highlight the kind of dry April through the beginning of July, really mostly just looking at the slope difference between our current water year and the normal water year. So you could kind of see the gap kind of picking up at the beginning of April and kind of persisting essentially till probably start of July here. So we have gotten the atmospheric system that Larry was talking about before. That's bumped us a little bit closer to normal, but the gap is still pretty big. Now moving to snow in the top right plot areas. The top center plot is the snow water equivalent in the Pacific Northwest region. So again, starting at the beginning of the water year, the y-axis now is snow water equivalent instantaneous values as opposed to accumulated values. compared versus the precipitation. The black line is the current water year. The light green line is the median line with the median peak SWE as the cross. And then I believe the last water year is in this orange line below it. So our peak SWE actually looked, slightly above the median peak SWE values, but it did peak earlier than normal. So that we'll discuss some of the earlier runoff in some future slides. And then on the right-hand side is kind of a newer product that I've been looking at. It's provided by the National Snow and Ice Data Center. It's called, I believe, the Snow Today product. It does provide a snow-covered area, which is a blend of, I believe, satellite assimilated data and then also some model data. So it has the current water year in blue. So we did reach a peak in, say, mid-February after a lot of storm events and flooding events, and then it has since trailed off to near normal conditions, which is the dashed median line. And then finally, in the bottom plot area, we have the stream flow data for the 7-day average runoff for the Pacific Northwest region. So kind of a sum of all the gauges that we were looking at. Larry kind of gave a different slice of that, but here's it's kind of just progressing through the water year. And then again, highlighting, at the beginning of April, we were kind of straddling that normal to above normal range, and then has since dropped to the 10 percentile range with maybe that slight bump up due to the atmospheric river, but it's quickly receding back to that lowest 10 percentile range for stream flow. Now, looking at what's being stored, just a quick look at some U.S. Bureau of Reclamation products here, or reservoirs, some of their bigger reservoirs at least. This is a ArcGIS dashboard in that link there. So the size of the circles are the size of the reservoirs. Near normal conditions are in the grayer shades, and then the kind of cooler colors are above normal, and the warmer colors are drier than normal. And so just highlighted some teacup diagrams with some explanations on the right here. So great, just highlighting that Grand Coulee and Hungry Horse, some big reservoirs, are right around near normal conditions for this time of year. I did want to highlight maybe some reservoir deficits, particularly in the kind of upper Snake here, the Palisades and American Falls. We also have one, I believe, along the Payette here that's riding below normal. And then there's this target sign in the Yakima for Cle Elum, which I believe is close to record. I believe the target sign indicates like one of the lowest recorded measurements for this time of year for that reservoir. Now, looking into the future a little bit, we have our 10-day precipitation forecast, or a lot of times we label that as quantitative precipitation forecast, and that's used in our ensemble streamflow prediction system, or ESP10. So on the left-hand side is just our 10-day accumulated QPF for the 10 days, and the color scale here is in absolute inches. Typically for water supply purposes, I look at the red shade the most, so we see some places in the upper Snake here, and we see on the right-hand side the same plot, but presented as percent of climatology. So again, looking at things in percent of normal. So we do see probably some reprieve here for the southern portion of our basin. Now, looking at our ESP10 water supply forecast, so we kind of have it bucketed into three major flow stems. In the blue here is the Upper Columbia, which has the pinch point at Grand Coulee. And then in the yellow area, we have the Snake contribution with the pinch point at Lower Granite. And finally, we have the summation downstream at the Dalles, taking in both Coulee and Lower Granite in the green. So just kind of walking you through the time series graphs. A lot of this is observed now, denoted by the blue bar graph. So these are monthly stream flow volumes and denoted in blue. We have our normals denoted as the green dots, and then we have our remaining forecasts denoted by the box and whisker plots there. And right now for Grand Coulee, we are writing at 78% of normal. This is a drop from last time Amy talked at 86, that was writing at 86%. So 8% decline. That's pretty sizable given the amount of contribution that Grand Coulee contributes to the Columbia River system. And you could kind of see that dry spring, April, May, June really populate here, particularly for the May, June, and July runoff. So prime snowmelt season. So that lack of snowpack in that kind of the the Rockies area is particularly the Canadian Rockies is showing up there. And so, and now moving down to the lower Snake, a Snake at lower Granite, we have our forecast volume not too different than Grand Coulee at 79%. We did have a bigger drop from the last time we talked, from 93%, so a 14% drop off. We did want to highlight maybe some timing of the melt here. We did see a bump up in March, which was slightly above normal. The blue bar is above that green dot, so it could just be some timing of that. So maybe that April through September volume would see higher percentages if that had run off a little bit later. But this area still gets that precipitation deficit in that spring-summer time frame is really showing up here, particularly in that June time frame. And then when you sum this all up at the Dows, we're riding at 77%, a drop of 9% since the last time we gave a presentation here. And so again, highlighting some pretty big deficits for that month of May through July. And now looking at the Climate Prediction Centers, or CPC's monthly and seasonal outlooks. The top row is our monthly outlook, and the bottom row is the seasonal outlook. And pretty similar stories for the temperature outlook. So the warmer colors just indicate higher probabilities of warmer than normal temperatures. But for the precipitation outlooks, for at least for the month of September, and then September, October, November for the seasonal outlook, we do have some higher probabilities of above normal precipitation for Western Washington and Northwest Oregon, areas that hopefully will definitely need it. And then we do have a pretty big swath of equal probabilities, but at least for the month of September, we do have some higher probabilities of below normal precipitation, unfortunately, for a lot of Idaho and parts of Western Montana. And now looking at the El Nino Southern Oscillation Index, or ENSO predictions, I believe the predictions are kind of highlighted here in the left and center plots. Pink arrows kind of denote the October, November, December kind of projection for that. And so I believe the ONI index is right around 56% chance of hitting La Nina. And then on the right-hand plot is a plot from our website that we kind of create April through September kind of historical correlation with of our volume runoff versus kind of the oceanic Niño index. So kind of negative 0.5 indicating La Nina. So typical La Nina year, sometimes our trend line, which has a really weak correlation value, keep in mind, it tends to indicate potentially wetter than normal conditions, which the normal line is denoted by this horizontal green line there. And then our current water year is hard to see. It's denoted by a box and whisker, but since we're so late in the season, it almost looks like a horizontal line. So this is where our current forecast is ending up right now for the Dows. And then finally, for a wildfire potential outlook, I believe I kind of skipped August because I believe the map was the same as September. Much of the Pacific Northwest is still kind of above normal significant wildfire potential outlook, but that begins to abate in fall. And just repeating some key takeaways, and just wanted to leave an ugly slide of all the links here. So. And that's all for me.
Thank you very much, Henry. And now we'll switch over to Alexis to hear about the Columbian Basin water management.
All right, great. Good morning. Let me start sharing my screen here. Okay, are my slides coming through all right?
Yes.
Wonderful. All right, so I'm Alexis Mills. I am with the Army Corps of Engineers in the Northwestern Division Office in Portland. I sit in Columbia Basin Water Management on the Reservoir Control Center team. And I appreciate the opportunity to be here today to chat with you about our Columbia Basin Water Management general overview and then current conditions that we're seeing on the ground. And definitely appreciate the context provided by Jason and Henry before this. All right, so we've seen the map of the Columbia Basin now quite a few times already today. But from a water management perspective, as folks know, the basin drains parts of 7 western states as well as southeast British Columbia. The headwaters originate in British Columbia and then drain obviously to Astoria. That's about 1,200 miles of river with a total travel time from top to bottom between 10 and 20 days, depending on the time of year. I've got a map there shown on the right, and that has the Corps of Engineers dams located and indicated by red dots, and then the dams owned by others in yellow. There are over 80 dams in the basin operated by multiple organizations. And one interesting fact, and something that we'll consider later as I talk about flood risk management, is that even though there's only about 15% of the basin located above the U.S. boundary, about 35% of our average annual flow comes in from Canada. So the dams in the Columbia River Basin are operated as part of a coordinated multiple-purpose reservoir system. The Corps of Engineers works with our regional partners to operate the system to serve 8 congressionally authorized purposes. For the sake of this presentation, I'll be focused on 3 of those. That is Fish and Wildlife Flood Risk Management, or FRM, and water quality control. So the federal dams are owned and operated by the U.S. Army Corps of Engineers and Bureau of Reclamation, but Bonneville Power Administration, or BPA, is responsible for marketing and transmitting the power generated by the federal facilities. The operations are coordinated between the 3 agencies in real time and on a planning basis. And in addition to that, we also depend on our working relationships with partner agencies for successful water management. And those partner agencies include additional federal agencies, so NOAA Fisheries and U.S. Fish and Wildlife Service. We've also have to have a relationship with Canada, or their proxy here, BC Hydro, in order to facilitate operations across that boundary. We work closely with the Pacific Northwest tribes and the states of Oregon, Washington, Idaho, and Montana. And I'll just say, particularly when we're dealing with fish passage season, which is the spring and summer months, we're meeting with those agencies and partners on at least a weekly basis to adaptively manage the reservoir system. So the first authorized purpose I wanted to discuss is fish and wildlife. So the dams are operated according to the federal proposed actions in our BIOPS from U.S. Fish and Wildlife Service and NOAA Marine Fisheries. Many of those targets manifest themselves as flow objectives or reservoir elevation targets, and then hydropower generation limits. We have a whole host of operations to complement the physical modifications of the dams to facilitate juvenile salmonid egress downstream in the Pacific Ocean, as well as provide suitable conditions for adult travel upstream to native spawning grounds. So we have a document that essentially governs our fish and wildlife operations for the year for the entire basin, and that's mostly focused on storage projects, but also run-of-river projects as well, and that is the water management plan. That is updated yearly by all the partners that I mentioned a couple slides back. For the context of this particular meeting today, I did want to point out that we have a set of dry year provisions in that document. A dry year per the water management plan is defined as an RFC May final forecast for April through August at the Dalles, less than or equal to 74.8 MAF. As Henry pointed out in his presentation, there was quite a dramatic drop off in the forecast. I think it was about 9% at the Dalles. So when we were looking back at May, we came in for that April through August forecast at around 75.6 MAF, which is obviously above that dry year threshold. But now, as we are closing in at the end of August here, we're looking at a observed value that'll likely come in close to 67.8. So that's actually well below our dry year provision. So we do have these provisions that allow us to adaptively manage during dry years. However, because of a rapidly changing forecast, we don't always get to implement those. So moving on to the second authorized purpose I wanted to discuss, which is flood risk management, or FRM. So sufficient storage space must be maintained in reservoirs to manage flows that would otherwise endanger health and human safety. I'm sure folks are aware that that's one of the Corps' major missions. We've got in the map of the Columbia Basin on the right, the major storage reservoirs that we in the Corps office are responsible for determining FRM for, and the relative amount of storage is shown by the size of the round dot there, and you can see the different ownership in that map key. So in the graph on the left-hand side is the average annual runoff and total active storage for 3 different river basins. The Columbia is on the far left there. So what I want to highlight here is that in the Columbia Basin specifically, the total space available for FRM is limited. So you'll notice that the average annual runoff is about 3 times what our total active reservoir storage is in comparison to the Missouri River Basin and Colorado Basin, which are also shown there. So what this really highlights is that in the Columbia Basin, there are few opportunities for multi-year storage or any carryover storage. So that's just not something that our drought contingencies usually plan for, again, because it's not possible. We get such a high runoff in the spring compared to our storage that it really doesn't necessitate or allow for that carryover storage. I also, and I should have pointed out on the last slide, there's a significant chunk of our storage is up in Canada. So we've got 3 storage reservoirs up there that were built because of a treaty with Canada back in the 60s. And the intent was to improve flow on the Columbia River. So the reservoir storage up in Canada is operated to reduce flood flows and shift energy from low value periods to high value time periods. So essentially shift flow out of that low demand spring freshet to summer and winter months when we need more power on the system. Our flood risk management protocols incorporate the flexibility and allow the Corps to maximize the potential to fill during a drying water supply forecast, as we saw this year. Our procedures vary by basin and are specific to the typical meteorologic conditions of that basin. For example, we have reservoirs in rain-driven basins, such as the Willamette River dams, and as Henry mentioned, their flood season is not driven by snow. But then on the eastern side of the basin, those are primarily snowmelt-driven basins. So very different management strategies with respect to the basin type. Shown here is an example of our storage reservoir diagram for Grand Coulee, which dictates the extent of drawdown required at the dam. And then there's also a headline there from last year highlighting requests granted by the Corps to hold the pool of Flathead Lake in Montana higher than typical. The reservoirs are released to refill as soon as possible based on residual snowpack and diminishing probability of flooding. The third authorized purpose I wanted to hit on during this presentation is water quality. So during warm, dry years like 2025, releases of cold water from storage projects is a critical way that the Corps manages the reservoirs to benefit aquatic species. To help cool water on the lower Snake River, Dvorak Dam, pictured in the lower right and indicated by the star in the upper right-hand corner in Idaho on the North Fork, Clearwater River releases cool water. The diagram on the bottom here, this is a Sankey diagram, and it shows the lower Snake River system with cool blue water coming in from Dvorak here. And that is because there is such a strong thermal stratification that water at the bottom of the reservoir remains cool through the summer months. And then you can see the warm water coming in from the middle snake here, this orange color coming in from the bottom. The difference between the incoming middle snake river water and the temperature in the lower snake river water, which is mixed with the cool water from Dvorak Dam, is shown above here in this graph. So you have in that, so in that top graph there is the temperature of the river in Fahrenheit, and the yellow or orange line is above the lower Snake River Dam, and then that blue line is the water temperature below Lower Granite Dam. So as you can see, that cooling water is successful and does ultimately cool the water below the temperature of the incoming Middle Snake River water. All right, so moving on to kind of what we've observed this year. This is the Columbia River flow at the Dalles. Here observed flow is in red, and the unregulated flows, or those without the flows without dams, are in blue. The bold and dashed black lines are the historic unregulated flows, and the percentiles are listed there in the plot. And what I really wanted to call out here is that there, as has already been mentioned multiple times in the course of this meeting, very low spring and summer flows this year, with the unregulated flows in July tracking close to the minimum unregulated flows for that historic period.
Would you be able to wrap up in the near future, Alexis?
Yes, sorry, yes.
Thank you.
And so we did touch full or near full at most of the reservoirs this year, again, based on the storage and lack of storage space based on average annual runoff that I mentioned earlier. This is Arrow Reservoir up in Canada. And again, we are slightly below normal, but we anticipate that we will catch up to that come fall and December. This is based on our ESP modeling results from our model, and the green dashed line is the observed median elevation on the top, inflow in the middle, and outflow on the bottom. And then lastly, I did just want to show the Dalles flow as well. So again, these are the results of our ESP modeling results, with that green being the observed mean. We will have minimum flow requirements that will likely govern our regulation in the upper basin through the fall, and we'll transition to higher flows for an operation to support chum salmon in November, which is that uptick in flows. So again, just want to call out that we operate the reservoirs for multiple downstream benefits. Because of the high runoff to storage ratio, Columbia Basin reservoirs have limited opportunities for multi-year storage, and reservoirs are adaptively managed during dry conditions for FRM and other authorized purposes, and forecasts and current reservoir levels indicate that minimum requirements will be met for the remainder of the water year and into the fall. And that is it, and apologies for going over.
Thank you. Next, we'll hear from Irvin from the Kittitas Reclamation District.
Thank you, Holly. Thanks, Jason, Henry, and Alexis. I will bring us home and talk about what's going on the ground in the Yakima Basin. Next slide, please. And we started out in the Yakima Basin earlier this year. Actually, in April, we actually thought we had about a 58% supply, and for the paratable or junior water users that we have here in the basin. I will just quickly describe the three main ones that get hit by the reductions in the Yakima Basin. There's about 500,000 acres total of irrigation, and there are about half of those that are paratable, primarily the Wapato Irrigation Project on the Yakima Nations Reservation, the Rosa Irrigation District, and the Kittitas Reclamation District are the three primary paratable or junior entities that absorb the losses. Also, the fish and wildlife impacts are significant as well. So we started out at 58%. With that dry summer and the heat that came in, we actually ended up on August 7th with a reduction down to a 40% supply. those late drops really have a significant impact on fish and farms. We have normally a system that shuts off on October 15th. Our Kittitas Reclamation District, which is about 60,000 acres, shut off on August 13th. So a little more than 2 months early off, no water for farms. And we'll be talking about what are we doing about that. Next slide, please. Just a quick look at that. This is, you can see the upper Yakima Basin. There's an upper left, Ketchlis and Cochise and Cleellum, those reservoirs up there. Those are the Yakima arm. There are also a couple more that aren't on the map that come off of the Natchez arm, which are the Tieton Dam or Rimrock and Bumping. The blue lines down there around Ellensburg really is that's the Kittitas, depicting the Kittitas Reclamation District system. The diversion is actually at Lake Easton up by Ketchlis and Cochise. And what we'll be talking about is how that irrigation system actually intersects a lot of tributaries that come out of the mountains and flow towards the Yakima River. Next slide, please. So what we're doing about it, and this is through the Yakima Basin Integrated Plan and all of our partnerships that we have in the Yakima Basin, is a significant water conservation effort within our district alone. Since the start of the integrated plan, we have saved through lining and piping 9,450 acre feet of water savings, which we are improving the distribution systems at the same time. So we're making better deliveries to farms, and we're allocating the saved water to help out the ecosystem for fish and wildlife purposes. Next slide, please, Holly. And here's an example of one of the first projects that we had done. This is Menashtash Creek. It's about, it's a North Fork and South Fork up above in the forested area. There's about, 28 miles of habitat up in the mountains from that stream. It had been blocked for about a century, with about a 3.5 mile stretch of that creek on its way through the alluvial fan headed to the Yakima River that had been going dry. So you can see on the left, 2011, that's what it looked like before we started our program. Conservation and then putting water into streams using the storage system in the canals to do it. Same shot, 2019, just added water. We're getting the roots, getting the shade, and then getting the passage for multiple species heading up into that canyon. 2023, same shot. That's shows the improvement. Next slide, please. This is just really quickly, the integrated plan has the goals, and I'm not going to go through all those, but it's, we've got a changing hydrograph here. What are we going to do about it? What can we do about it? And we've put together about a 30-year plan for having a healthy economy and a healthy ecosystem moving into the next couple of centuries. It's about a $4 billion plan. Next slide, please. Back to the irrigation district, one of the ways that we're responding to these droughts that continue to be more severe and continue to come as back-to-back droughts. We're right now in our third consecutive year of drought in the Yakima Basin, and we still haven't recovered from the May of 2023 major heat event that flashed off. We lost about 250,000 acre feet in about a week in May of 2023, and we haven't recovered from that. And the soils up in the mountains in our watershed have not either. So one of the ways we're doing is working with our partners and putting in SCADA systems so that our operators can be watching in real time on their phones. Every 5 minutes they get an upload of what's going on throughout the district with flows. Next slide, please. As we're figuring out what to do about this snowpack that's not materializing, we're looking at storage. So in the Yakima Basin, we have about 1 million acre feet of storage, but we need about 2.5 million acre feet annually, and we're really dependent on an orderly melting snowpack, which isn't occurring. So we're implementing water conservation, but then we need somewhere to put that conserved water. This particular one is about a 3,600 acre piece of property that we worked with some of our NGO partners, in this particular instance, the Trust for Public Lands, and we're able to purchase the former Stuart Anderson Black Angus Ranch property. Has about 6.5 or 7 miles of Yakima River frontage, and one piece of that property has a perfect place for a surface storage. Right now, we're doing about a $21 million feasibility analysis to find a way to store somewhere between 20 and 100,000 acre feet of water. That water will be designated for spring smolt out migration and other fish purposes. As part of the deal with our planning partners that we were all able to put together, Yakima Nation got some of the property, Kittitas County has some of the farmland to protect, and the Department of Fish and Wildlife are also partners. The Kittitas Reclamation District is holding the reservoir site while we do the analysis. Next slide, please. Just real quickly, the integrated plan, there are 7 elements. So we have fish passage at all the reservoirs that we have in the basin. The fish passage wasn't included when they were originally constructed. The first one that we've put in is at the Cle Elum Reservoir. You can look that up. It's a helix, first of its kind in the world that we know of to get water out of that reservoir as it's moving up and down. I mentioned surface storage. We're also looking at groundwater storage. We have a lot of habitat and watershed protection, so a lot of forest health that projects we're working on as well. More water conservation, structural and operational changes. That's really using the existing infrastructure for purposes other than what it was originally constructed to help us be resilient to this changing hydrograph that we are being presented with much quicker than what we thought we were going to when we started putting this program together. And of course, water marketing is important as well. Next slide, please. This is just, we're working on trying to find a way that we can support municipalities, the irrigation entities, instead of having a 40% supply year and multiple droughts in a row. We're trying to get a stable supply for the junior or paradable irrigation district, work on getting the all stocks of fisheries back to harvestable and sustainable flows. And again, we have lots of partners, and we're making a tremendous amount of progress, but these droughts just keep coming more frequently, and they are lasting longer. Next slide, please. And let's see which one. It's not, there we go. Okay, groundwater storage. Yeah, this is really important. So down on the Yakima reservation, you can see down in the bottom right, there's that pink area. So there's just below that, there's the out in the Toppenish area part on the reservation. They're doing tremendous work with groundwater aquifer recharge. Then the city of Yakima is doing aquifer storage and recovery, where they're putting water down in and pulling it out. Upper Yakima Basin, we're working on aquifer recharge as well. Where it says Upper Yakima System Storage, that's a location of that Springwood Reservoir project. And then we've been looking at other storage opportunities as well, but again, those studies continue. The Springwood Reservoir is the one that we are focusing on, but it's really looking at a series of surface storage reservoirs and groundwater storage throughout the basin that will help us with our flows. And next slide, please. That's just a picture of the celebration that we did with the Yakima Nation on their portion of the Springwood Ranch property. That was a couple months ago. And next slide will be the partners slide. And I bought us a minute. Thank you very much for working the slides, Holly.
Thank you very much, Urban, and thank you for all of our speakers today. We do have a time for a quick question. This one is for you, Henry, just asking for a recap. Missed the information on the equatorial conditions currently across the Pacific right now. I think we're in neutral, but which way are we heading in terms of fall and early winter?
I believe we have entered in La Nina as the forecast. But I think it just crossed. So yeah, at least for the October, November, December timeframe, which tends to have the highest correlation value, that seasonal ONI prediction. So hopefully that answered the question. So.
Yes, thank you. And then a question for Urban. What is the Springwood funding source?
Oh, thanks. Excellent question. Consistent with the Yakima Basin Integrated Plan, the funding source is through federal authorization. So 50% federal, and then state policy statute in support of the Yakima Basin Integrated Plan, 50% state. So state and federal. Thank you.
Thank you very much to all of our speakers. Here again are their emails if you'd like to reach out to them if you have any additional questions for them. And a recording of this webinar and other resources will be shared in an email here shortly and on drought.gov. Thank you all for your time and attention.